Hi everyone, Assalamualaikum. In this video, we are going to continue with example for integration by U-Substitution. Now we look at example 8. Evaluate integration from 0 to 1 to x over square root of 3x squared plus 1 dx. Right, from the given question, we have division function, okay? And we also have integration sign here, means we need to integrate. Be careful, never use quotient rule to integrate as in differentiation. Alright, since this is division function, some student tends to evaluate using quotient rule, but this is integration. Okay, no product rule, no quotient rule, and no general power rule in integration. Alright, so you must be careful. Alright. In this case, we can use U-substitution since the function x squared here and x from numerator here can be related with derivative. Alright? Alright, from the given question, this is definite integral using U-substitution. Okay, because we have lower and upper limit here. Okay? Alright. To evaluate definite integral using U-substitution, first step, we can solve indefinite integral first. Okay? So when we solve indefinite integral, we just write integration sign without lower and upper limit. Okay? So we can write integration of 2x over square root of 3x squared plus 1 dx. Alright? To evaluate indefinite integral. Okay? So from here, we can move square root to numerator here and we can write 2x times 3x squared plus 1 bracket to the power of negative half. Okay, using the properties of indices. Because from denominator here, square root here means bracket to the power of positive half. So when we move up, we get to the power of negative half. Okay. Alright, from here, we have multiplication function. But remember, never use product rule to evaluate integration. Okay, this is not derivative. Okay, so we cannot use product rule to evaluate integral. Okay, alright, so from here, we can use U-substitution because we have x squared and x here. Okay, which can relate with derivative. So when we use U-substitution, first we identify U. Okay. Alright. We can choose U equals to 3x squared plus 1, the function inside bracket. Okay. And after we choose U, we need to differentiate. We differentiate U with respect to x, so the symbol becomes du over dx equals to, we differentiate 3x squared, we get 6x. And then we differentiate constant, we get 0, no need to write. Alright, and after that, we write dx as a subject, which is equals to du over 6x. We just cross multiply. Okay. Under U-substitution, after we identify u, and then find du over dx, and then write dx as a subject. So the next step, we rewrite in terms of whatever u and du. Alright. So from here, we can write 2x times u to the power of negative half, and then dx, we can write du over 6x. Okay. Alright, the steps are, we replace 3x squared plus 1 by u here, so we get this. Okay, and then to the power of negative half. And after that, we replace dx. From here, we have dx equals to du over 6x. So we can replace here. Okay. Alright, after that, we can simplify 2x and 6x in denominator here. And we get over 3 here. Okay. And after that, we can move out constant 1 over 3. Okay. And then we have integration of u to the power of negative half du. From here, we get term containing u and du, no more variable x. Okay, so from here we can integrate with respect to u. Okay, so if we make the right choice of u, we can simplify or eliminate all the variable x from the given question, and it easily can solve the integrals. Okay, alright, so after we get variable u and du, so we can integrate with respect to u. Okay, and then after we integrate, we still have constant 1 over 3 here, and then when we integrate u to the power of negative half, we have u to the power of half over half. We use this formula. Okay, when we have integration of u to the power of n du, okay, where n not equals to negative 1, okay, so we can write u to the power of n plus 1 over n plus 1 plus c. Now our n equals to negative half, which is not equals to negative 1. So we can use this formula. So from this formula, negative half, we plus 1. Okay, so we get positive half here. And then n plus 1 means negative half plus 1, we get half here in denominator. Okay, so we get this. Okay, and after that we put plus c because now we solve indefinite integral. Okay, with no lower limit and no upper limit. So we must put plus c. Okay, alright, after that, from here we have fraction and over fraction here. Okay, so we can write over half here. We can write multiply by 2 over 1. We just exchange numerator and denominator. Okay, and then we have u to the power of half and then plus c. Okay, after that we can simplify constant, so we get 2 over 3, and then u to the power of half, we can write square root of u or set u and then plus c. Okay, and from here we can replace back. We done integrate, so after we done integrate, so we can replace back u equals to 3x squared plus 1. Okay, so after we replace u, so we get 2 over 3 square root of u equals to 3x squared plus 1 plus c. So from here until this point, we done integrate. Okay, but we just integrate indefinite integral. Okay, so next step we can find definite integral. Okay, alright, from the previous slide, okay, we solve definite integral using U-substitution. First step, we solve indefinite integral first. Then we get this answer. Okay, we get integration of 2x over square root of 3x squared plus 1 dx, which is indefinite integral without lower limit and upper limit, equals to 2 over 3 square root of 3x squared plus 1 plus c. Okay, this is what we get in step 1 in the previous slide. So after we done step 1, after we solve indefinite integral, so we can continue with step 2. We solve definite integral. Okay, so to evaluate integration from 0 to 1 to x over square root of 3x squared plus 1 dx. Okay, alright, we have 2 over 3. 2 over 3 is constant, so we can move out. And then we write square root of 3x squared plus 1. But we must put square bracket with lower and upper limit. No plus c. Okay, plus c only for indefinite integral. Okay, when we solve definite integral, no need to put plus c, but we need to put square bracket with lower limit and upper limit. Okay, and after that, we need to replace the value of upper limit and lower limit. Okay, so we substitute upper limit first into variable x, and then in between is minus sign. Okay, and then we replace lower limit into variable x. Okay, we still have constant 2 over 3 in front here, outside bracket. Okay, and then we can simplify. We can solve. Okay, so we have 2 over 3. Okay, square root of 3 times 1 squared plus 1. This is square root of 4, which is equals to 2. And then minus, this is square root of 1, which is equals to 1. Okay, so we get 2 over 3, the final answer. Okay, this is the final answer, which is 2 over 3. When we evaluate definite integral from 0 to 1, 2x over square root of 3x squared plus 1 dx. Okay, alright. This is definite integral with U-substitution. Okay, first we solve indefinite integral, and then step 2 we can solve definite integral by substituting upper limit first, and then in between minus, then we replace lower limit into variable x. Okay, then we just solve the answer. Alright. Coming up next, more examples for integration by U-substitution. If you like this video, you can subscribe. Thank you for watching. Stay tuned. Bye. Assalamualaikum.